Now let's examine the data flow to the PyData archive from the data source. To begin with, we have the data source, which is not an OSIsoft product that contains the raw data. First, the OSIsoft Pi interface collects the data from the data source. At this stage, the Pi interface performs an operation called exception, where exception is the process of filtering out instrument noise that is gathered from the data source. For this purpose, a deadband is set up, which is shown by the rectangular box, where any point that lies within the deadband would be discarded. Note that exception and so-called compression settings that would be discussed shortly are included in the Pi point configuration itself. Considering A as the first point, B would be discarded since it is within the band. Since point D is outside the band, point D and its previous point C would be stored by the interface along with point A. Thus, only points A, C, and D would be stored by the interface before it is sent to the PyData archive via the buffering mechanism. Note that it would be a best practice to configure the buffering mechanism on the interface node. In short, buffering mechanism is vested with the responsibility to store the data before sending the data to the PyData archive. This mechanism becomes valuable when, for example, the connection to the data archive is not available. The data would be buffered in files on the interface node itself. Thereby, once the connection gets established to the PyData archive, the data from the files will be flushed to the PyData archive snapshot subsystem, thereby ensuring no loss of data. Then once the data arrives to the PyData archive snapshot subsystem, which enables you to query the so-called current values, a process so-called compression is applied before the data is archived. In this process, only the slope of the line is taken into consideration, where a similar deadband is applied to the data. In this example shown, only points A, E, and F would be stored in the archive. Thus, when a user tries to retrieve the data later to plot a trend, for example, interpolation would be used to connect the data points between A and E, thus eliminating the storage of intermediate points, namely B, C, and D. It's worth noting that before the data is passed from the snapshot table to the archive, it passes through a buffering mechanism called even queues implemented on the PyData archive, which would facilitate the storage of data in the even if the archive subsystem is either busy or unavailable.